So the bank beneath my feet is all about the organization of life and the organizational strategies of life. It's very different perspective, what they are and how we can actually apply that to build sustainable economies, right? So in the next 25 minutes, I'll take you through my inspiration, and I think I've already covered a lot of the inspiration points, so I'm just going to skip over that. The science behind all of this. Then I take you to some new insights that come from this science, and innovative solutions, how we could start developing solutions on this insight. Because one of the big things that scientists look for is a meaning to their research and to see the real impact of science. So when you do theoretical work, or you come up with a new theory, or you come up with a new idea, you want to see how that connects to make a difference in people's lives. And that's the thing. And so we have a solution in sustainability, which I take you from insight to solution end to end in there. So here was my purpose. I was first chasing my career. It was what doctor, engineer, lawyer. Then suddenly I became a rebel, and my parents were distraught. The brain fry years when I had like a free reign to run and study whatever else I wanted to study. And then, like I said, during my business stint, I realized how we had such a big blind spot towards the environment, towards our society, and towards ourselves. I thought that, there was a joke going around in college. They say, look, you learn linear algebra, you learn calculus, you learn all of those important things, and then the brightest minds are all working on Excel sheets. Right? And that's pretty much what I thought, that hey, am I really missing the big picture? And somehow I thought that, look, if I want to change that, how do I actually change that? And that's what I thought. This is an analogy that people say, travel broadens the mind. But I think time travel broadens the heart. And how does that happen, right? So if you think about it, you're sitting at home with your cup of coffee or tea, whatever beverage of your choice. Go through your photographs over the last 10 years, 20 years, with your family, with your friends, all of that, and you'll realize and you'll find where you're coming from. What are the good moments? What really, really matters in life, right? And if you know where you're coming from, you can face the future confidently. Because you know where you're coming from, you know what decisions to take, and what really matters to you. So I thought that this was a great way to really think about it, and I thought with science, provide that bridge between my mind and my heart, so that I could actually reach out and go through this photo album of life to see where we are, and hence maybe make a deeper connection between our living systems and people around us. So that's what I did. It was a lot of, when I started flipping through the album of life, it started some 3.5 billion years ago. 3.5 billion years ago, and I want you to get a grip over these things. Sometimes when the condo board gets an election period of 5 years, right? Some bolte are yaar bahut lamba hai. 1 saal ka hona chahiye. Think about what time frames we think about, right? And here is 3.5 billion years, right? That's the time frame that life is evolving over and really developing the strategies, refining the strategies. So it took 3.5 billion years for our planet to create the first living cells from molecular pathways, the first living cells. Then the next, at 1 billion years it took for it to create multicellular organisms. This is phenomenal because that's like the invention of DNA. So by that time, life had figured out how to make DNA and how to make that a language for ecosystems. So huge transition point. At that time, that really created ecosystems because now you had plant producers, multicellular plant producers, and consumers, which were animals. And 300,000 years. So think about it, almost 2 billion years. 2 billion years it has taken for humans to evolve. The first species with language, and the start of commencement of our socio-economic system. And now, in just 30 years, we have the next one looking at us, AI. Right? So we're seeing how living systems have evolved, and this is what I engaged myself with. 5 years of deep research. During the day, read through the papers, and those papers are quite dense, extremely complex. And in the evening, Zoom calls, Skype calls, visits to meet up with the leading stalwarts of science. And this was very, very different from the normal research that we do. Why was it so different? It was different because it required a width which was phenomenal. It spans all the way 3.5 billion years of evolution. And second, we were not looking for structures. We were not looking at what species evolved. At every point in time, we were questioning what were the organizational strategies that life followed. The organizational strategies that life followed to give rise to to make the transition from molecules to single cells, from single cells to multicellular systems. What is the organization of ecosystems? And is that an organization that continues into social systems? So instead of having an economist only study economics, what we did is we would put an economist together with a mycologist who studied fungi, together with a gut bacterial scientist and a monetary systems expert, and tell them that, look, across these levels, do you see similarities? It was phenomenal. It was the best time of my life, the 5 years. And what came out of it was this research which got published by the International Society for Information Studies in Vienna. It's a very prestigious university institute which includes all the most famous information scientists worldwide, like including Alan Turing and all of those guys. And they invited me to Vienna, and they published it in this book. This is the largest chapter in that book, right? And so this is the first time that we explore the natural roots of our socio-economic organization. So when you say, who created this company? We come up with a name, right? So we said that, look, businesses, markets, banks, our language, all of those things have their roots in biological evolution, not social evolution. So it was a path-breaking work that came out of it. And this is, after this publication, then I was in multiple scientific forums. Usually don't speak on ordinary, to lay people, but Vaidi told me that you have to simplify it enough, right, so that everybody understands. So I've tried my best to do it. Everybody understands. Everybody understands. And actually what happens is that anytime my cricket team, it finds a ball beyond the shoulder level, they say no ball. So if it goes beyond the shoulder level, please let me know, right? And then I'll simplify it even further. So the key takeaways in the first 5 slides, which also is a good suggestion from Vaidi, he said, look, every 5 minutes, summarize. So what are the key takeaways? A study of our past brings important understanding of who we are. If we don't look at the past, we're just chasing something that's there in front of us. We don't take a look at, we're not understanding the big picture. Second, it takes a different kind of a large-scale, multi-level science to understand nature's organization. Right? Something that normal scientists who are working within disciplines miss out on. And the third thing is, remember, our society, banks, businesses, language, all have their roots in biological evolution. So the next time you think very important of yourself, remember, you are just the doer of life's long strategies, and I'll show you how. Right. So the insights that came out, what came out of this research? The first thing that came out of our research is that organization of our banks is an extension of the same organization in ecosystems. Right? Phenomenal. Nobody would have imagined that. And we're now thinking in terms of solutions is, can we integrate ecosystem economics and human economics? It's a tremendous opportunity. Think about it, 500 million people now can work to regenerate ecosystems. So if you're consuming it as humans at the rate at which we are, we're also incentivizing and have some investment avenues for people to grow it. Right? So it's a phenomenal opportunity. The second is, language is not a human invention. but it's nature's tools to create hierarchies. So every time, and ours, human language, is the third language in evolution. Third language, we're not the first language. And every time nature has created a language, it has been created and given to a species which has worked for billions of years just to give rise to another level above them. Right? So if we've learned the language, and they've given us the language, and we dominate the planet because of our language, we've created money, we've created economics, we're creating rules, we are doing all of that. Remember one thing. You're here to create the next level of language. And that's going to be the future for us. It's an inevitable future for that. Now, this was the important observation. And so the question is, can we shape the emergence of the next level of intelligence, which is AI? Right now, AI and businesses. The third most important insight is there's an energy cycle at the core of social organization. What does this mean? Just like we have an energy cycle in ecosystems, whether it's producers, plant producers, animal, consumers. Now there's a similar energy cycle in ecosystems, in human society, right? And that means that everything that is, all the properties of energy cycles, including, dissipation of families and communities, right? So for instance, as businesses take on and as economics takes on, there will be an automatic fragmentation of families and communities. That's the reason why people have become rich, busy, and lonely. And now we're starting to get some real insights on what is driving that epidemic that you see spreading across the world, and why is that affluent societies start facing these problems. And we're now looking at new solutions for that with this new understanding. So it's been a phenomenal journey with some very interesting new insights. I'll take one insight on nature's financial network and show you some ideas on how this insight, get into the depths of it, that's the topic, the bank beneath my feet, and see how this led to some ideas on creating exchange between human economics and ecosystems. So here is 3 levels of production in ecosystems, right? At the first level, we have molecules, and plants use photosynthesis to convert these geochemical molecules into living cells, right? That's what we understand about photosynthesis, that they take in nutrients from the soil and they make living cells. So that's what plants do. Then these plants become food for animals, right? And at the third level of organization, some animals have learned to create a unique social structure, which is that their families create children. And many animals have families that produce children, but here, these children go to work for organizations that are not their family. And this thing where kids go to work for businesses and human resources are now starting to flow in this cycle is actually the energy cycle in society. And this is very unique to humans and is dependent upon the emergence of language. So this is basically sums up the production, consumption, production of human resources, consumption of human resources. 3 levels that shape our society and our lives today. Now, what has happened is at each level, there is a banker. So for instance, at the where geochemicals are being produced, and I'd ask somebody, who produces these geochemicals that become nutrients for plants? Anyone? Yeah. Soil bacteria, right? So there are millions of bacteria in the soil that are actually producing the geochemicals, and releasing those geochemicals, nutrients as we call them, like iron, like calcium, like phosphorus, all of that from the soil, and making it available to plants. And here are millions of species of plants in a forest, or hundreds of thousands of species in a forest. They're all competing for these resources. What happens typically when there is railway tickets, 5 railway tickets, and 200 people waiting in line? Gunda gette. There is a chaos, right? So to avoid a chaos and to create a distribution of these resources in an economic framework or in an economically sustainable framework, nature invited one fungus called arbuscular mycorrhiza, AM. It says, sir, you create a banking network where all of these resources can only go to plants if they pay for it. Whoa. So what this fungus does some 400 million years ago, this fungus captures all the phosphorus that's available in the soil. And why does it capture the phosphorus? Does anyone know why phosphorus is called the energy currency of a cell? Because it is the key to produce ATP, adenosine triphosphate, which is where all living cells capture their energy. And what that does is that plants cannot produce photosynthesis without phosphorus. It says, okay, I will now capture all the phosphorus, and that becomes its money. Anything in short supply which people cannot do without becomes the money. And so now this is the money of phosphorus, and it's investing in these trees. These trees are all getting only that much money that they can actually provide return to this fungus. And in return, what do the trees provide? They say, hey, we don't deal in phosphorus currency, so we're going to give you our currency. And their currency is carbohydrate, because that's what they produce and that's what works in the higher order ecosystem, which I'll show. So they exchange this phosphorus and carbohydrates in this network. Just another question. What percentage of all this energy and carbohydrate produced by these trees do you think is actually getting into this network, this fungal network? One fungal network. 5%, 2%, 20%, 25%. Any guesses?
25.
Huh?
25%.
You close. 25%. So a quarter of everything the plants produce is going to this bank. Remember, our BFSI sector also accounts for a large part of the GDP. Unusually large part of the GDP. And a lot of people question, why does it account for such a large part of the GDP? It's because that is the tendency in nature, that the banking networks have an overweight always in terms of these kind of self-organizing systems. So here you have mycorrhiza, and this created the Mycorrhiza Bank Limited. You can call it My Bank, MYAMB Limited, and 30% of all ecological GDP is going through here. Now the carbon that's coming to this mycorrhiza, what does it do with it? Well, it doesn't sit on it. It has created nature's first MCX, multi-commodity exchange. It takes this carbon and it tells the soil bacteria, anybody who would actually give me the nutrients in demand, I'm going to give you the carbon, payment in carbon, in carbohydrate. So it starts collecting selenium, magnesium, all of those things, and it starts selling it back to the plants. Right? So you have one company, the Mycorrhiza Bank, right? And if any of your investors PE guys want to invest in that, this BFSI asset is available for investment. It has been around for 400 million years, so your money is not going to be lost. So think about it. What a fantastic arrangement nature has done to just make sure that what is produced is distributed, and how this entire financial network is being set up in one fungal species. Now at the next higher level, we have millions of species of autotrophs, that is plants, becoming food for so many species of animals. And again, these guys also want the food. So some species can come and eat up all the food and the others don't get anything, right? So how does nature create the same balance? It says, well, it has to happen on economic principles. What do you take, you have to return back, right? So it has created yet another banking network. This is in the bacteria that sit in your gut. So your gut bacteria determine how much of the food that you eat, the calories in that food, gets into your system and how much gets out of your system. Sometimes you'll see in ecosystems, large number of insects suddenly coming out. You know, like thousands of insects, millions of insects suddenly. And you say, how the hell do the insects know when to multiply? Gut bacteria in their body change. They give them the calories. They suddenly get all the signals to multiply, and the insect population grows. So your gut bacteria are controlling carbon, right? Investment across species, and in return for work. So what? Over a long period of time, the evolutionary studies that look which animal is helping plants increase photosynthesis during that season and in that particular kind of environment. And that is all the information stored in your gut bacteria. So when you think about 100 trillion gut bacteria that reside in us, don't pull out your sanitizer. Right? Because these bacteria are you. They are life, and that's your connection to the ecosystem. So we see now a lot of sugar metabolism in humans that's going haywire. And there's a lot of research that's going on, is that what is the connection with environmental health? Because these gut bacteria are managing carbohydrate assimilation in your body, which is modulated by the insulin system. So there's a tremendous environmental connect. We feel that we just can eat whatever food we have and we have to change the diet and all of that, but environmental health and animal health are directly connected through this kind of a system. And the financial markets the next time. Families are here producing children, and these children need a job. So again, to prevent gundagardi, humans created the system of financial markets or banks, and they're saying that these banks will invest in businesses, and wherever the investments go, that creates an environment where people can get jobs. So your employment changes as per changing demand and supply of whatever those business sectors are producing. So here is a 3-level organization, right, of living systems where all these 3 are interconnected. Now what do we know? And the first question you ask is, why is our economics unsustainable? What can we learn from the bacterial systems, right? So the first thing you ask is, look at how beautifully synergy has been created by the living organisms. Here are geochemicals. Mycorrhiza are investing phosphorus and getting carbon in return. So those species that produce the most carbon get the most phosphorus. Clear? So this part is all geared up to increase photosynthetic production. This part, those animals are getting investments of carbon that are producing and helping plants produce more carbon, more carbohydrate. So both together are synergized to increase carbohydrate production. Human businesses are printing money like a casino. We don't know why they're connected. We are decoupled from the ecological system. And so far we didn't know there was an ecological system, so we never realized this. It's only when we started flipping through life's photographs and its photographs of these organizations that we realized that, hey shit, this is a real big missing piece. So key takeaways of this section on findings is that one is that money and banks are not human inventions, but a natural property of self-organization in living systems. As bankers or investors, we're only operators of nature's schemes. We're not the owners, we're not the creators. Even a fungus can do what we are doing. So it's like that. Second is we have much to learn about this organization, processes and sustainability from ecosystem banking systems. Right? And we're just beginning to undertake those kind of research where we're actually starting to figure out how do you bring sustainability into finance. And third is monetary innovation will be a cornerstone in any effort towards sustainability, because unless you find a way to integrate human economics with ecological economics, things are not going to work. So let me give you now, with this insights, how did we go about making a solution in the last 5 minutes. Okay. So we know good news that the economy is growing between 1985 and now it was 12.5 trillion, now it's 125 trillion. And we're all sitting here because it's grown and we've all become affluent. More people are getting employed. 2.28 billion in 1991 is now some 3.29 billion. So almost 1 billion people have found employment. The bad news is on all the environmental front, species extinction, greenhouse gases, land use, water, we are, there's no good news there. Then there's a huge environmental crisis. And I feel that more than for us, we're shortchanging our kids unless we change track on that. So everything that they have, if they don't have health, they don't have the environment, and if things are going to get bad, that's not the way intelligent species would take things forward. So we have to shift gears there. So what's happening is, why is it been such a difficult problem to solve, if you ask? It's because now we know that there are two economics. You have human economics, which operates on our currency, our money systems, our set of assumptions, and there's an ecological economics, which is operating differently. And it's a conflict between two systems that are operating at two different levels. And not just, it's a global conflict. So you have to align these systems at the city level, town level, district level, country level, and then globally. So it's a huge task and a difficult task, unless you can start synergizing economics with ecosystems. And how do you do it? Well, in very simple terms, we ask ourselves a question. If these guys are operating on a currency, and these guys are operating on a currency, can we make these currencies exchangeable? If UK is operating on a pound, and India is operating on rupees, for trade, can we make the currencies exchangeable? Have we done it? Is there a floating rate that comes out based on supply and demand on what the pound should be valued and what the rupee should be valued? Is it possible for us to do it here? Wow, that'd be phenomenal. If we're able to do that, we'd have solved a long-standing problem. And so this is what we got started thinking about. Well, what's the problem? The problem is that we are taking all of things that are currency to nature, which is our toilet waste, and 655 million liters of untreated sewage, which contains phosphorus, nitrogen, calcium, all the nutrients that we need, is all going into the sea. Right? So every time we flush our toilet, it is equivalent to a demonetization for the ecosystem. Right? And we've been doing it for years. Correct? Because we didn't know that was their money. We thought they were just ingredients and just nutrients, and you throw phosphorus in the soil and it can get taken up. No, and that's the reason why our soil health is declining so rapidly. So we said, how do you change this? So we got a bunch of engineering students. It was just another talk like this, and I like to work with young kids. So I got a bunch of engineering students and asked them the question. I had the same presentation. I asked them, how do you solve this problem? We want to synergize this. And after about a week of deliberation, right, we call this exercise as a sustainathon. Right? We bring these kids together and we give them a problem and we say, okay, you solve this problem. So after a week of deliberation, they came out with a roadmap. So what did they say? They say, hey, we know phosphorus is the currency of living systems. Fine. So every time 1,000 kilos of potatoes are taken out from a farm, you geotag the farm, and you know what is the content of phosphorus that has gone out in the 1,000 kilos of potatoes? Fine. You compute that phosphorus and you debit that farm on a blockchain. On a blockchain, you debit the farm for that much quantity of phosphorus. Any biomass reprocessing unit, like your sewage treatment plant, which is today throwing that away into the ocean, that puts this phosphorus back in this farm on a blockchain, gets credit, and a new currency is created, green cash. This green cash is exchangeable for Indian rupees. So now you're printing money, new money, in rupees, not just on whim, but for bringing back to life an entire reverse supply chain for biomass. And this was one week's work with these kids, right? There were so many new ideas, because this still doesn't solve the problem like we have at Imperial. We have taken away 3 acres of land, which used to previously be a forest, right? Now, what about all the biomass that was getting produced there? Now, we're not pulling out any wheat or crops from here. So, can we really create an asset value for phosphorus flows by incentivizing people to plant native trees and to recreate ecosystems in buildings like this? That's a different solution. So, we want to run another version of the Sustainathon, and we're looking for leaders and mentors for young students to run this kind of a competition. And if you guys are, any one of you is interested, you can connect with me. I'd be most happy to, the kids would be most happy to get this leadership and this kind of guidance. So after all this, I set up this organization called LifeL, which is a non-profit catalyzing cutting-edge science and sustainability solutions. The goal is to develop new age socio-economic models integrating ecological, social, and economic sustainability. So we're looking at a number of things, including, like I said, social issues. How do you integrate social society with economics? How do you integrate? How do you look at AI and make AI more humanistic? Right. So all of those kind of problems that we're doing through deep science, new insight, and innovative solutions. Just like to leave you with a quote from John Muir, who's one of the fathers of the national park. It says, "We are nature's servants." Just as you start flipping through the pages of nature, it becomes clear that look, what we're doing is nature's schemes. We're just running the schemes, entrusted with the stewardship of our planet, and it's our responsibility to care for and protect the delicate balance of the natural world. So he was not here when all of these ideas were coming out, but I tell you, his heart was in the right place, and that was important.